Are you familiar with the concepts of polymorphism in C++? In this video, I'm going to talk about function overloading and operator overloading. And I'm also going to talk about the operator keyword in C++. Let us dive right into this video and see exactly what these mean.
Good day everyone, my name is Oguchi Beze from Beaverman Technologies, and in this tutorial I'm going to be talking about C++ overloading. Overloading in C++ is the process of creating multiple implementations of a method or procedure using the same name, but different number of parameters or different data types. There are two types of overloading in C++, function overloading and operator overloading. Function overloading is the process of having two or more functions with the same name, but with different parameters. Let's go ahead and check an example. Let's say I have a calculator class, calculator, and I'm going to create a public method for adding two numbers. So this is supposed to return an integer. I know the function is add, and it takes in two arguments. I have int a and int integer b, and this function simply adds the two numbers and returns the sum. I can go ahead and create another, which is the overload, by say int, same add function here. I'll pass in again int a, int b, and int c. So in this case, this second function, or this overloaded function, is going to add three numbers. It's going to take in three numbers and then add them together. So this is the second function. I'm going to also create a third one, add, and this is supposed to take in A, B. Sorry, I think I should have a double here. So A and double B. That's what I intended. So this is going to return A plus B, the sum of the doubles. So we have three implementations of the add function, and now if we decide to create an instance of calculator and run an add function, which one are we going to be getting? Actually, this is going to be dependent on the number of parameters passed very easily. So let's go ahead and see exactly how this works. So calculator, cal, have no constructor, so I don't need to specify that. So I'm just going to do a cout. Let's see a sum of A and B. I'm going to be specifying any A and B, but I'll just go ahead and call cal.add. I'll see, and so what are the parameters that we can pass into our add function? So let's say I add 10 plus 8. Of course, this is going to be referring to the very first function because both data types are integers, and I have only two variables here. I have only two values here. So I'm assuming that this function is the one that's going to get called, of which that is the one that will be called if we run the function. So I'll just click run. So of course I see 18 printing out the screen right there. What if I go ahead and add in a third parameter as specified by my add function? Let's say in this case I add in 30. So if I run this function this time, we say that I have 48, and this function runs successfully. And you can see that in this case the C parameter jumps right into this place. So what if we go ahead to decide to add in doubles? So let me say I want to add in a double, 10.2 and 6.4. Now this is a double, and we have only two values. Of course, if I hover on this, you will see that the type resolution, I have double, and the function resolution, sorry, I have a double and double. So this goes ahead to recognize immediately that I need a double version of the add function. Then it does the resolution and returns the value. So we see that we get 16 here. Oh, sorry, this should be a double. So double right here. So we're getting an integer and we should return a double instead. So it works just fine. Now this procedure works of function overloading works the same for default constructors in general, and also index properties. So we can use this in those categories too. Now, even using function overloading could seem a bit simple, but there are caveats that we should always pay attention to. Now, because of, in this case where I have double, there are cases where if I change this to float, for instance, A and float B, now because C++ by default is going to want to change these values from float to double, although it's a valid float, but then the most comfortable type for decimal values in this way in C++ is doubles. And then because we are putting in decimal values here and we have float as the data type of our parameters here, float is also a valid data type, but then there's going to be a typecasting from float to double if we pass these values in here. We should try our best to always avoid any kind of typecasting, because this function relies on the type of data passed in here to be able to find the function to call. So we should try also, as we're specifying whatever value here, we don't use float in this case, we always use double, so that any implicit typecasting that is going to be happening will be avoided. So we have to do double here, and this function is going to run just fine. Another caveat that we also should be very aware of is using default values. Let us say, for instance, I have a default value here, 20.6. Now, the number of parameters that needs to be passed here could be 2 or even 1 at this case. So now, if I go ahead and remove this value, this is valid. But then there's a trouble with, if I have, let's say, for instance, an add function, a double add function that takes only one parameter, then my program is going to struggle with trying to resolve whether it's going to use the add function with a single parameter or this one with a default parameter. So we should always try to make sure that we are explicitly avoiding doing this in our program, especially when our function is being overloaded. So I'm just going to do back so I get that. And the last caveat we're also going to need to pay attention is when we are passing parameters by reference. Let's say, for instance, I want to pass by the ampersand right in front of here. So this is how we can be able to pass parameters by reference. So we should also beware of this, because any value that we pass by reference, because the type is being checked here before the function is resolved in this point, if a value is passed by reference, this reference value type is only a reference in memory, and it is not any type at all. It's only a reference to a double. So the parameter passed here is like an address or pointer. So it is going to be an integer in this case, and we should always be very mindful of that. We cannot pass this in because it's going to go ahead and break our code in C++. Now, having said that, let us jump right into operator overloading. So I'm just going to clear my screen. So what is operator overloading? Operator overloading is used to overload or redefine most of the existing operators available in C++. It is used to perform operations on user-defined data types. Let's say I have a data type that I have specified. Most times, if we want to define a data type inside of C++, just like in the case where I define the calculator as a type, you go ahead and create a class for it, class or struct. These are going to help us define a data type inside of C++. So let us assume, for instance, I have square. Just going to use this example, square, and in my square class, I have a length. Okay, these are private variables. So I'm just going to specify that these are private. So say the length is an integer. So say int ln. Also say int for the width. So a square should have a length and a width. Then I'm going to have a public function going on here. So first I'm going to place a constructor, so square The constructor is going to take two integers, let's see, L and int W. So all my constructor does is to assign values for my length and my width. Let's say L and WED equals to W. So let us say I want to go ahead and create a function. This is an idea to add two squares. So if I was to add two squares, I'm going to have to create an add function. So this returns a square. Of course, I need a square as a return type. I'll say add, and then I'll write the function. Of course, I'm going to pass in a reference to square, should be, and the job of this function is to do, say, length. So I have there is equal to len, a private variable plus p of len. I also say int, and then my width is equal to wid plus b plus width. Sorry, b dot width. So of course this is how I'm going to be able to add two squares. So if I add the length, it's going to be the total length, and I add the width of the square passed in plus my normal width, and it's supposed to give me the width. So I'll just go ahead in the end and return a square. Return square. So I'm going to use a constructor there, and this square is going to take in the length as a parameter and the width here, second parameter. So of course this function is well written, and we can go ahead and see this function work right. But lastly, I'm going to add in a print function. Variables are private, so for me to do a print, I'm going to say void. Let's name that properly. Let's say print. So this is just going to see out the length, which is passing len, and also see the width is, and they are passing the width WED, and the end we just say endl. I'm just going to specify comma right here. Now I can go ahead and create an instance of a square. I think I need two in this case. I say square SQ. I say this is equal to, I'll use my constructor square, and let's put in two values. So say 20 and 5, and I place in another two values. The second one I intend to add, I say square SQ1. I say this is equal to, I use my default constructor to define that square, and this should be 10 and 6. So these are the two variables that I need in that case. So I'm going to go ahead and call the add function now, but this is going to return a square, so I'll call this my third square. So it's SQ3. So SQ3 is going to, instead of me to use the default constructor, I'll add two squares for me to be able to get the third square. So I'll say SQ dot add. So this returns a square. So I'm going to add this one. I'm going to add it to SQ1. So if I return this function, it's supposed to, if I return the value of this function is supposed to return the square, which is for SQ3. Of course, it returns a constructor here. So, alright. So then finally, I'm going to go ahead and do a print on SQ3. I think I should place that with 2. That was consistent with my values. So say SQ2. So if we go ahead and run this function as we have it, so see 30 and 11. Of course, this does a valid add. It adds 20 to 10 to make 30, and also adds 5 to 6 and makes 11. So this does a valid add. But then one thing that we need to also pay attention to is that the fact, even though we use the add function in this case, we can also go ahead and use the add operator, which is the plus sign. So if we use the plus sign and create a function around the plus sign, it's going to be able to alter or modify the add for the add sign or the add symbol to be able to do a valid addition of these variables. So that is what we call operator overloading, and we're going to go see exactly how we're going to be able to achieve that. So in this case, for me to go ahead and modify this function to be an operator overloaded function, I can just go ahead and change this. I'll say this is, I'll use the operator keyword, say operator, spell that right, operator, and then I'll place in the sign that I want to overload. So if I have operator, I'm going to place in the sign, and the sign I'm trying to overload is the plus sign. So of course this is very valid code, and if we run this code like this, we're not going to have the add function. All I'm just going to need to do is modify this, which is going to say sq plus sq1. So this is also valid, and if we go ahead and run this code like this, we see that we get the same result, even though I'm not calling that add function as we have it again. So this is the magic that we have inside C++. So you can see that our operator plus sign, operator plus, has been overloaded in this case. So if I just say sq1 plus sq plus sq1, I go ahead and get the same implementation of the add function. And this makes a whole lot of sense. So let us see a more comprehensive example, or a more comprehensive solution using operator overloading. So in this case, I overloaded the add function, or the add operator, sorry. So, but you can also overload any other operator, like the less than, the greater than, and so many other operators, the minus, the plus, and so on and so forth in C++. But then I'm going to also show a very comprehensive use of operator overloading. I'm going to use this add in this case, and we'll see how that works. So first things, I'm going to go ahead and get rid of this code, and I'm going to be creating a class called duration. So I'll say duration. Now this function, this class is supposed to harbor some minute, an hour, second variable that I need for that should be private that I need for my addition. So I'll say as. I also have minutes. I also have in this case seconds. Then I'm going to go ahead and create public function, and the only function I need here is first the default constructor duration. Duration is going to take in 3 integers, so I'm just going to go ahead and place in 3. I'm not going to implement the functions here. And I'm also going to have a second function called the operator overloading. So I'm just going to do operator plus. So I want to overload the plus sign addition. So I'm going to take in a time t, and then the last function I'm going to do, just like we did before, is a print. So I'll say void and say print. So I'm just going to implement these functions in a moment. So the first thing first, we're going to implement the default constructor. So I'm going to have duration, and I need a constructor there. So in this case, I need integer for hour and this integer for minutes. I also need integers for second. So we're going to pass in the default constructor as should be equal to h, minutes should be equal to m, and seconds in this case should be equal to s. So this works right fine. So the second function I'm going to implement is my overloaded function there, which overloads the. So I'm going to pass in the class. This is the return type. So the first value, the first duration is the return type. Then I'm going to also see the. So I'm going to pass in the operator. So this is going to use the operator keyword, and the symbol I'm overloading in this case, like we said before, is the add. I'm going to pass in here the data type of duration t. So of course I want to make this a reference, so I'll pass in the value by reference anyway. So in our implementation, I just want to go ahead and create my logic right in here. So you might have actually seen such a logic before. So I'm going to create temp, which is temporary duration, and it's going to hold the value of this. Now, this the current object being created. So that is what is going to be held here. So it's going to be held. I'm going to create so the temp dot seconds. This is equal to, I will need to add the seconds with t dot seconds, which is a new variable that we add there. We're going to pass in seconds, and then I'm going to do a modulo 60. So this is supposed to return if there is an overflow of seconds, because if our seconds exceed 60, it's supposed to give us the remainder, because the maximum or the highest seconds number I can have is 60. So if it passes 60, I just want to go ahead and roll back the remaining numbers behind. So also I'm going to do that same for the minutes. So minutes also doesn't need to pass in seconds, but then first of all I'm going to take in the number of minutes that it captured from the seconds and add it to the current seconds that we have. So I'm going to do this by saying seconds plus t dot seconds and this time I'm going to divide by 60. So I want to place some brackets so that I have my duration first. So if I divide by 60, I'm supposed to see the number of minutes that I can be able to get from this second. If the number is more than 60, at least I have 1 second to reckon with. And then I'm going to add this with my default minutes, the minutes from my object, and then I'm going to also add the t dot minutes. And it's the new variable added, the new object added in there. So of course I'm just going to wrap this inside of brackets. So I want this division to happen first. Of course the compiler is going to do division first before addition, but let me explicitly state that that's what I want. Then finally I want to also make sure that this number does not exceed 60. So if it does exceed 60, I want to roll back the hours, because 60 minutes is 1 hour. So I want to roll back into the hours what we get from the minutes. Hours, and this will be equal to, I'll just copy this implementation from here till the end where we did the modulo. Yeah, I'm just going to go ahead and paste that. Then I'm going to divide by 60 to get the wrapped around minutes. The minutes that are up to 60 minutes. And then I'm just going to go ahead and add the hours. Say hours plus t dot hours. So this is supposed to get the duration that I need. Of course, my hours could be any length of hours. So I'm not going to go ahead and wrap any value around. So my hours could be, much less. I'm talking about duration in this case. And then in the end, I'm going to just return 10 as we have it. So let us go ahead and implement the last function, and that should be the print. So this returns void, and then it's from the duration class, and the last function we want to implement is the print. So this is not going to take in any parameters, so I'm just going to do cout. Cout the duration is, then I'll need, it should be right outside, so I'm going to see hours and then I'll say hours right here. Then I'm going to specify the number of minutes, so I'll say minutes and then I'm going to specify the last variable, which is for seconds. So this is supposed to print out, I'll say NL the end. So this is supposed to print out the duration actually passed in using the value. So I'm just going to go ahead and create an instance of this, and I'm going to also use operator overload. I'm going to use the add operators to see how we can put this into practice. So I'm just going to go ahead and instantiate a duration class called T1, the duration object in this case called T1. So I'm just going to use my default constructor to give values to this. So this is supposed to be 20 hours, 15 minutes, and then 54 seconds. Let's say that, for instance. And I'm going to also instantiate a new duration called T2. And in this case, in my constructor, I'm going to duration. I'm going to place in 3 hours, 15 minutes, and 20 seconds. So of course, let's go ahead and add these two duration and then see what we can be able to get. So I'm going to have the third duration T3, and this is going to be a sum of T1 plus T2. So let us see what we get as the parameter and the third duration. So I'm just going to say T3 dot, I'll use the print. Okay. So let's go ahead to see the value or the parameters that occupy the T3 hours, minutes, and seconds of my video. So run this code, and yeah, we'll have 24 hours, 41 minutes, and 14 seconds. Of course, if we go ahead and do our math rightly, we'll see that this is very correct, and this is how we can be able to add two duration together to get a single duration. So this is how we can be able to use this addition. This addition is supposed to add two single data types or value data types like numbers or integers or strings. But then in this case, you can see that it is doing something a lot different, adding hours, minutes, and seconds. So this is exactly the concept that we're trying to explain when it comes to operator overloading, and it makes sense that we can actually be able to use this in the way that we can. So thank you. This is my video. I'm going to meet you all in the next one. Thank you very much. God bless you.